So what we need to do here is find the number of ways of forming 4-digit codes in which no digit is repeated. So what we have to understand is that if we have no repeats, well, our n value here is going to be 10, because for each option you have 10 digits to start with, and we are picking 4 of them. So, thinking in terms of permutations, we have our 10 total, and we're permuting out of that 4 of them, because we're saying that the order is important here. The order is important in a combination, at least usually. Although that might hint that we shouldn't call them combination locks, but that's something we'll talk about later. So we have 10 factorial ways that we could select 10 unique digits. But we don't need 10, we just need 4. So we're going to say, all right, let's ignore the other 10 minus 4 of them, because that's way more options than we would ever need. That is, we're going to ignore the 6 factorial arrangements for the other 6 digits after we pick our 4 to make the combo. So we'll space this out a little bit. We've got 10, we can pull out a 9, we can pull out an 8, we can pull out a 7, and we'll get down to a 6 factorial. It takes a little bit of practice to get used to seeing that that's where you want to end up, but hopefully it's a little quick to notice that you want to be able to cancel what's on the bottom, so you want to be able to pull it out somehow. In this case, it's not so hard. Just pull out a 9, 8, and 7 and you're there. You can cancel out this 6 factorial with that factorial, and you'll be left with 10 times 9 times 8 times 7 for a total number of options that we have seen before, that we saw pretty early on actually when we were talking about the fundamental counting principle, of 5040. So it's important to remember here that everything we're working on is just specific uses of the fundamental counting principle, where our values happen to fall into specific patterns based on what we need. So instead of using the fundamental counting principle directly every single time, we can use a shortcut. But the principle still works, if that's what you prefer. It's just, when we're working with nice patterns, why complicate it? And that is definitely the case here, but for all these, we're assuming that the order is important. But a lot of times order doesn't matter. And using the fundamental counting principle directly for that sort of thing, it's a bit tricky to figure out what you need to take care of with that. So to make our lives a little cleaner, we have a construction called combinations. And that's what we'll be seeing next.